Welcome back in Module 2 of this course. In this video, we will be discussing Lesson 3, Reducing Changeover in the Workplace. In the last lesson, we learned about the 5S methodology and improving the workplace, and how it can be the foundation for a visual factory. In this lesson, you will learn how we can reduce changeover time using the technique known as SMED. Before going into the specific steps of SMED, let us first define what is changeover and what is setup. For changeover, it is the amount of time taken to change a piece of equipment from producing the last good piece of a production lot to the first good piece of the next production lot, as defined by Gemba Academy. In a non-manufacturing setting, a changeover is the amount of time taken to divert from the last good unit of one type of work to producing the first good unit of the next type of work. Setup, on the other hand, is part of the changeover. It is a preparation part, or the adjustment performed for the process every before a new lot or a new type of task. So in changeover, it is from the moment the process is stopped up to the moment the process has produced the first good output of the next run. So based on the categorizations of activities when we analyze processes, the changeover is actually part of the SBA or NDA category. In Lean, we focus on eliminating or minimizing the non-value activities. SMED, or the single-minute exchange of dice, also known as quick changeover, is a technique used to reduce the changeover time. The main idea of SMED is to reduce the changeover time to less than 10 minutes. This is to reduce the changeover time to a single-digit count of minutes. This is done by diagnosing each element of the changeover to see if it can be eliminated, moved, simplified, or maybe streamlined. SMED is one of the Lean techniques, and just like the others discussed in this module, it is done through the PDCA cycle. It is about standardizing and then improving. It is not a one-time improvement that from your current setup, it can be reduced to the most ideal time for your process. It will undergo iterative process improvement. For example, if you can recall this video regarding batching from course 1, batching is done because it takes time for organizations to change from one process setup to the next, especially if they are using large machineries. One cycle of SMED may reduce a percentage of your current change over time. Therefore, we can reduce the quantity produced per batch, resulting to a shorter lead time. But it can still be improved. Also, as demands get higher, the more do we want to reduce or change over time. One example of SMED or quick changeover is the fire pole system in fire stations. The firemen usually have their break areas on the upper level of the station while their trucks are parked below. To make traveling from the break area to the changing rooms faster during response, poles are provided so the firefighters will just need to slide down the pole instead of taking the stairs. Another is the design of their suit. Their safety boots and pants are connected, so during response, they can change into the suit faster. Another illustration of reducing the setup operation time is this observation during a cocktail preparation. The process of the bartender goes, walk to the shelf to get a glass, then to the prep area. Then, walk back to the shelf to get a paper coaster, then back to the prep area. Walk back to the shelf with the filled glass. Get next ingredient and fruit decoration. And finally prepare the cocktail to be served to the guest. In this process, there is potential reduction of the setup time. This is by eliminating the steps in the gray and blue boxes being combined with the step in the orange box. The suggestion was to minimize the walk time of the bartender during the preparation of the things he needed for the cocktail. He can use a tray, to carry multiple items towards the cocktail preparation area. So why do we need or why would we want to have a quick changeover? It would be to reduce defect rates. Quick changeover reduces adjustments as part of the setup and promotes quality on the first piece. It will also reduce inventory costs. Elimination of or a reduction in the numbers of batches and their sizes allows for recovery of operating cash and manufacturing space. It can also increase production flexibility, increase output, and improve timelines of response customer orders. Improve on-time delivery. Quick changeover supports the ability to meet customer demand. A changeover or the setup operation consists of activities from cleanup to startup. These activities can be categorized into two types, the internal and external. Internal activities are those that can only be performed while the process is inactive. These are the activities that can only be done during the changeover procedure. External, on the other hand, are what we call activities that are performed outside the changeover procedure. We can do these activities even when the process is active or in manufacturing while the machine is running. The time for the external activities combined with the time for internal activities compose the total changeover time. For example, before we can change product types in the tumbling machine, we need to do some necessary setup activities. To differentiate internal activities from external, we need to establish when is the process active or inactive. In this case, the process is active when the tumbling machine is running. The process is inactive when the tumbling machine is stopped. The elements for the changeover are weighing the chicken and the other ingredients, cleaning the tumbler, and setting the correct tumbling time for the product. We can classify the weighing activity as external, since this activity can be done even while the tumbling machine is processing another batch or another type of product. Cleaning and setting the tumbling time activities are internal, since these activities are performed only once the machine has finished the tumbling process. This can also be applied to changing of shifts or handover between shifts in restaurants or in offices. SMED is a step-by-step process and it has three main stages. Before the first stage of SMED, we have the preliminary setting. This is when the activities in the setup operations are still not classified between internal and external. Observing the whole setup operation and recording all details of each element is done during this stage. After listing down all the elements of the setup operation, we will then classify each activity as internal or external in stage 1. The next stage is to convert internal activities into external activities using techniques such as advanced preparation, function standardization, and the implementation of intermediary genes. Once all possible conversion is done, the next stage is to streamline all aspects of the setup operation. This means we will now try to simplify further the remaining activities, both external and internal. A more detailed discussion of each stage of SMED will be discussed in the preceding slides. The first step of SMED is to establish all elements of the setup operation. This is done during the preliminary stage. In the preliminary stage, we observe the current process of changeover. Some of the common or basic steps in a setup operation are listed in here. We need to record each step in the process by sequence and the time taken. After which, we may show the video to the setup person and other people involved in the setup. Ask the setup person to describe what he or she is shown doing. Have the group share their thoughts about the operations. Study the video in detail, noting the time and motions involved in each step of the setup. Also, you can use a stopwatch if necessary. Taking this for example, a small-scale industry has this setup operation when changing from one variant to another. The subject equipment is a BMC, a metal cutting machine. In the preliminary stage, they used a data collection table and stopwatch capture the process. They also identify the tools required and the operator's condition for each step. The current changeover time is 339 seconds. After that, we may now proceed to stage 1. In stage 1, we segregate the observed process steps in the preliminary stage as internal or external. We will divide activities in these two categories. Remember, internal activities are those done while the process is inactive. External activities are done while the process is operating. From our example, the changeover process activities for the BMC were also classified. In this case, almost all of the changeover activities are done when the machine has stopped. Total internal activity time amounted to 151 seconds, while the total external activity time amounted to 188 seconds. During internal activities are the only times as observed when the operator is actually working. The external activity is the machine run. The operator at this time is idle. From the total changeover time, almost 40% is dedicated just to do the setup. That would mean only 60% of the total time is the process actually value adding. The next stage is stage 2, convert internal activities to external activities. In this stage, we will identify which internal activities can be converted to external activities. We will check which activities can be performed before and after the process is made inactive. Some of these are organizing items and pre-assembly of items needed for the changeover. So why do we need to convert internal activities to external ones? Doing so will reduce the time the process is made inactive. Because during internal activities, we stop the production run. But if the activities are external, the process is still ongoing while we do these external changeover activities. The runtime of the process is not affected. Here are some internal activities that are most likely convertible to external activities. Tooling, proving, or preparation, preheating of dies and plates, preloading of information, presetting of tools and equipment, using of jigs and setting aids, transportation of materials, and other equipment. Of course, internal activities cannot be converted to external in the blink of an eye. Your external activities or internal activities are currently done only during changeover for a reason. Converting them into external will need some changes in the current process. Here are some practical techniques to do this. Advanced preparation of operating conditions, function standardization, and using of intermediary genes. Other techniques include the following. We can use checklists in order to ensure nothing is overlooked in the setup operation. List everything required to set up and run the next operation. Checking items off the list before the machine is stopped helps prevent oversights and mistakes. Establish a specific checklist for each operation. We can also perform function checks before the setup. It will tell us whether the parts are in perfect working order. This checking should be done well before setup begins so that repairs can be made if something does not work right. We can make improvements on the transportation of the things needed for the setup operation. Dies, molds, tools, jigs, gauges, and other items needed for an operation must be moved between storage areas and machines, then back to storage once a lot is finished. Transportation of items should be done during external setup to shorten the time the machine is shut down. So during observation, we have to watch out for transportation, motion, walk times done during the changeover. There are a lot of other ways to convert internal activities to external, but in this lesson, we will cover more on the details of advanced preparation, function standardization, and use of intermediary jigs. Advanced preparation of operating conditions. This means getting necessary items and conditions ready before the internal setup begins. Conditions like temperature, pressure, or positioning of materials can often be prepared externally. This is while the process is ongoing. For example, Let's say you have a spool of wire stock to be used for feeding a new process. Normally, new spools must be brought to the machine by a forklift, but a forklift isn't always available right away. Waiting for a forklift will be just an unproductive time. A temporary holder can be built. This holder is loaded with a new spool while the machine is still running. When the end of the old roll is reached, the operator simply pushes the new roll into the position and then the process continues. The next technique is function standardization. When tools or machine parts in a new operation are different from those in the previous one, operators must make time-consuming adjustments during changeover, often with the machine shutdown. When we say standardization, we keep something the same from one operation to another, and it will help us get rid of this internal setup. One example is making identical parts whose functions are essential to the setup. To do this, we will look closely at each individual function in the setup process and decide which functions, if any, can be standardized. For example, we have a process where we need to do some data analysis on a certain set of data. The raw data encoded in Excel and comes from different encoders are submitted, and then we run a software for the data analysis. However, templates for the raw data vary from one encoder to another. This will lead us to an additional step of data cleaning before running on the software. Standardizing the raw data template among encoders will eliminate the data cleaning step. The last technique is intermediary jigs. In many processes, intermediary jigs can be used to change internal setup tasks into external ones. These are plates or frames of standard dimension that can be removed from the machine. For example, multi-press dies mounted on an intermediary jig. Using the intermediary jig, replacing the dies after a machine run is easier. Going back to our example, the small-scale industry was able to convert several of their internal activities into external. In order to convert internal activity to external activity, they focus on the tasks related with material handling, information gathering, adjustment, and control. They introduce palette change and error-proofing techniques such as methods of orientation and tool setting. We now enter the last stage, streamline all aspects of the setup operation. In this stage, all remaining internal and external activities are improved by looking at each operation's function one more time, making each as efficient as possible. Improvement is divided into two parts, external activities improvement and internal activities improvement. External activities improvement usually include storage and transportation of parts, tools, and other items required for the changeover so that these items are well organized and ready for the next operation. For example, in this diagram, a trolley cart is used to transport parts, tools, and documents to the machine. At the same time, it serves as a storage of these items. Before the machine stops, the cart is set up next to the machine so that the unloading and reloading is done immediately. The cart design, particularly the height, also matches the machine's design so that there are no lifting during reloading. Rollers are also employed for easier movement. Part of the external activities improvement include the preparation and organization of items required for the setup operation. This is where 5S comes in. Keeping the workplace in order and visual, eliminate activities such as looking for needed items. Another example is the use of return addresses on dies and shelves. This is also applicable to other items such as folders to shelves. Setting a place for a specific item and labeling them appropriately will help reduce unnecessary motion of searching for the items when it is needed. The positioning of the items on the storage may also be given guides so that when it is pulled out, it will be easier for the user. This return addresses sample is also applicable to warehouses. Location boards may be employed as a directory for the pickers in order to reduce moving around the warehouse trying to look for a particular item. For internal activities improvement, these following techniques may be used. Parallel operations, using functional clamps, eliminating adjustments, and mechanization. Parallel operations divide the setup operations between two people, one at each end of the machine. This will eliminate time spent walking back and forth for the operator of the setup. To help streamline parallel operations, workers develop and follow procedural charts for the setup. Procedural charts indicate the sequence of the tasks each worker will perform, the time needed for each task, and when safety signals are supposed to be given. The next technique is the use of functional clamp. A functional clamp is an attachment device that holds objects in place with minimal effort and that can be tightened and loosened quickly. For example, this device holds a component during inspection. The clamping jaws will loosen or tighten by pulling or pushing one of them. Another technique is eliminating adjustments. Eliminating adjustment and trial runs is done by making good settings before you even start up the machine for the new operation. The number of trial runs and adjustments will depend on how accurately or inaccurately you perform centering, dimensioning, and conditioning settings in the earlier steps of the setup. We can eliminate these adjustments by using numerical scales and making standardized settings, making imaginary center lines, imaginary reference planes visible, and using the least common multiple system. Eliminating adjustments requires operators to rely less on intuition and more on constant numerical values for machine settings. Examples are use of graduated scales, gauges, shims, spacer blocks with fixed numerical dimensions to set a distance reliably each time. For example, here in this photo, a spacer block is used to set up a component for inspection in a coordinate measuring machine. The blocks eliminate measuring the needed spacings before running the program for inspection. Making center lines and reference planes visible is an effective strategy for eliminating adjustments. In this photo, the component is loaded in a platform with holes, which serve as grids. The grids serve as reference for the positioning of the component on the platform. Many operations performed on one machine have elements in common, where similar things are done but with different dimensions, patterns, or other functions. The LCM system makes these common elements into a mechanism that can handle the different functions needed. During changeover, the mechanism stays in the machine and only the functions changes. In this sample photo, LCM is demonstrated by the clamp. The clamp can be used to hold components with a diameter within a certain range. When a new component needs to be loaded into the inspection, there is no need to get a new clamp. If the program for the inspection also considered LCM, their location of the component within the platform does not need to change as well. The last technique is mechanization or automation. Mechanization should be considered after every attempt has been made to streamline setups using the previous techniques. There are two reasons for this. Mechanization will only reduce time by another minute or so. Mechanizing an efficient operation may result in time reductions, but it will not really make the process better. Mechanization is usually essential for moving large press dies, die casting dies, and plastic molds. Some practical techniques include using forklifts for insertion in machines, moving heavy dies on bolsters, tightening and loosening dies by remote controls, using electric drives for shot height adjustments, and using the energy from presses to move dice. Going back to our example, the small-scale industry streamlined their external and internal activities, which resulted to a reduced total changeover time of 256 seconds from the original 339 seconds. Employing the palette change and error proofing techniques were their way of being able to reduce changeover time by 24.5%. This reduction led to an increased production in terms of quantity, from 198 to 258 units per day, and on the per month basis, 4,950 to 6,450 units. As shown in this example, the change in the total changeover time will reflect in other metrics of the process. In this case, it was reflected in the production quantity per day and per month. The decrease in the changeover time resulted into an increase in the production quantity. SMED has a direct effect on the availability of the process to produce output. If the changeover is short, the longer the available time. And if the changeover is long, the shorter time is there for the process to run, given that unplanned stops are constant. The OEE, as discussed in the previous module, is a measure of the overall performance of the process. For SMED, it comes in when we talk about the availability factor, particularly on the runtime or in other terms, uptime for the process. Again, if the changeover is short, the longer the available time. And if the changeover is long, the shorter time is there for the process to run. Changeover is included in the OEE analysis since it is time that could otherwise be used for manufacturing. While it may not be possible to eliminate changeover time, in most cases it can be significantly reduced. And this is the goal of SMED. To further illustrate the application of SMED, here is a case study on a hinging process for fashion iron. The case study is summarized as follows. Changeover time reduction at 44%. The changeover data analysis focused on the hinging process. One setup known as out-and-out setup takes about 1 hour to finish. The SMED technique implemented parallel operations. The fashion eyewear company applied SMED in these 4 stages. The team observed the current process of the out-and-out and setup. In the observation, they noted down the activities in the setup operation, the time it takes to perform each activity, and the type of activity, for example, preparation, assembly, and others. They also observed whether or not the activities were performed in front of the machine or away from the machine. They classified each as internal or external. The analysis of the as-is state had highlighted the opportunities of introducing some changes in the current setup process. They discovered that there were excess movements away from the working stations. There was difficulty in identification of the proper tools to be picked up from the shelf, and there was a lack of acknowledged sequence to perform the tasks. In stage 2, to convert internal activities to external, they conducted a trouble chart analysis, which can potentially reduce the excessive movements they discovered. They also introduced 5S plus tool trolley for potential reduction of movements for picking individual equipment. The trolley can be moved around the department by its assigned worker, and a specific worker was also assigned to keep the tool trolley in order and ready to use, adapting the 5S approach. In stage 3, they re-evaluated the activities in the setup in order to discover how they can further streamline them. For example, collecting the disassembled equipment into a box to be delivered to the shift advisor at the end of the setup process, with the worker leaving the machine only once. The supervisor successively sorts the equipment and properly stores it on the shelf. In a way, the activities were distributed to personnel involved in the setup to reduce excessive transportation for one person only. Also, to address the previously discovered issue on the varying sequence of activities in each set of personnel, training were conducted. The training started with the first meeting, in which all the proposals to improve the changeover process were explained to a selected and small subset of setup operators, with the participation of the management. The management involvement was fundamental to encouraging and motivating workers to embrace new solutions and commit themselves to the change. In this training, in order to assess if a worker had really understood all the passages, a good technique was to listen to him while retrieving all the steps by memory. The proposed rationalization of the changeover process led to a total setup duration of 30 minutes and 32 seconds, thus a reduction of 24 minutes 32 seconds from the original time. This is equal to a decrease of 44%. So again, changeover times can be dramatically reduced, in many cases to less than 10 minutes. Each element of the changeover is analyzed to see if it can be eliminated, moved, simplified, or streamlined. SMED techniques promote recurrent applications of the PDCA type cycles using scientific methods that repeatedly test increasingly more demanding performance targets. And changeover time is included in OEE analysis since it is time that could otherwise be used for manufacturing. While it may not be possible to eliminate changeover time, in most cases it can be significantly reduced. We hope that you were able to gain additional knowledge from this lesson. Thank you and hope to see you again in the next lessons.